Welcome to the week beginning October 19th. We're going to be looking at antacids this week. Antacids are simply weak bases, typically carbonates or hydroxides of aluminum, which partially neutralize stomach acid in a relatively harmless reaction. The reactions are a metathesis gas-forming reaction, which you've used on several occasions in lecture. The antacids we're going to be studying is a calcium carbonate. Calcium carbonate is the active ingredient in Tums and other generic forms of the same type of antacid. So the reaction in which Tums or calcium carbonate effectively neutralizes some of the acid is right here. So we have calcium carbonate and two hydrochloric acids. This is actually what stomach acid is. And when these two react, you get calcium chloride, which is just Ca2 plus, and 2 Cl minuses because it's aqueous, and water, and carbon dioxide. Now, carbon dioxide is a really uncomfortable side effect of this particular reaction. It produces gas, obviously, gas in your stomach. So they actually have anti-gas additions to tablets like Tums so that it doesn't relieve one problem and cause another. Now, as I said, we're going to be using Tums, also a generic form of Tums, and we're going to compare them. We're going to compare them both in terms of how well they actually neutralize acid, how much acid each pill neutralizes, and how much acid is neutralized per penny. Okay, so the cost effectiveness. Now, you might think that in order to analyze this, we would put our calcium carbonate in an Erlenmeyer flask and we would titrate it. So here's our calcium carbonate, and we would titrate it with hydrochloric acid, standardized hydrochloric acid. Well, there's a problem with that that results in our needing to use a technique called back titration. Why would we need to use back titration? Why not just straightforward titration? First of all, our endpoint in this particular case can be very poor. It's often very hard to go from a basic solution to an acidic solution given common indicators. Additionally, when you actually do this experiment this week, you'll notice that when the calcium carbonate and the hydrochloric acid react, it forms a hazy, cloudy solution, which makes the endpoint even more difficult to see. Secondly, calcium carbonate is not very soluble in water. You know that. Calcium carbonate is just chalk. And so you put it in water and it kind of gets mushy, but that's about all it does. It doesn't solubilize very well. So instead, we have to dissolve our antacid in acid, NaCl, just like it's meant to do. And then we have to figure out how much hydrochloric acid actually didn't react, the excess acid. We have to find out how much by titrating with a standard base. So effectively, we go too far. We add too much acid. The calcium carbonate can only neutralize a certain amount of it. The rest of it we have to neutralize with base. So here we start with our acid, and some of it gets neutralized by calcium carbonate, but what's left over we have to titrate with sodium hydroxide. There's just too much for the calcium carbonate to neutralize itself. All right, so the procedure we're going to be following for this back titration is that first we have to add that large amount, relatively speaking, that large amount of standardized hydrochloric acid to our tablet. All right, so we have a flask. Here's our Erlenmeyer flask again. Sorry about how lousy that little drawing is. Here is our calcium carbonate tablet. We're going to add a known number of moles of HCl into this tablet. This will allow the tablet to dissolve, because that, after all, is what the tablet's meant to do. It's meant to dissolve, not in water, or every time it got humid, your container of Tums would become mush, but in acid. The binders that hold it in a tablet form will dissolve in acid. So the first thing we're going to do is dissolve it in acid, and this is using that same reaction we were just looking at. Calcium carbonate plus 2 hydrochloric acids become calcium chloride aqueous, water, and carbon dioxide. Now, as you know from chapter 2, all reactions reverse somewhat, right? They reverse somewhat. So we have some reproduction of calcium carbonate and hydrochloric acid, unless we alter the products a little bit. And that's what we're going to be doing. We're going to be boiling this solution and getting rid of the carbon dioxide. If you get rid of the carbon dioxide, release it as gas, then you can't have a reversed reaction, and we won't have reforming of any acid. All right, so mathematically, the molarity of the acid, which Mr. Proetta will have figured out, times the volume, and you're all going to be using the exact same volume of hydrochloric acid, will give you the total moles of hydrochloric acid that you add to the tablet right at the beginning. Okay, so we've reacted it, we've boiled it to get rid of the carbon dioxide. We've got it nice and dissolved, except for those hazy binders that are still floating around. Now we've got to do the second step, which is to titrate that leftover hydrochloric acid, the unreacted hydrochloric acid. And we're going to titrate it with your standardized sodium hydroxide from last week. So I hope you did a really good job standardizing your sodium hydroxide. This particular reaction is one that we see all the time. HCl plus NaOH becomes NaCl and water. Now, we can figure out from our volume of titrant, NaOH is going to be in the burette. We're going to titrate it. We're going to know at the equivalence point the volume of the NaOH that we needed to neutralize that leftover or unreacted hydrochloric acid. Now, the molarity is what you figured out last week. That's you. The volume is from this week's titration, and that gives us the total moles of NaOH that are needed to neutralize that unreacted acid. Now, this is a 1-to-1 molar ratio. You can see that 1-to-1. So our moles of NaOH that we've just figured out times our molar ratio, 1 mole of hydrochloric acid per 1 mole of NaOH. Our moles of NaOH cancel, and that gives our moles of unreacted hydrochloric acid. Now, the last step is a mathematical step. We simply look for the moles of acid that were neutralized. That's the bottom line of this week's experiment, is to find out the moles of acid that were neutralized by the antacid. And how we do that is by the difference between the total and the unreacted. So total moles of HCl, which we got from step 1, minus the unreacted moles of HCl, which we got from step 2. That'll give us the moles of hydrochloric acid that were actually neutralized by the antacid. Now, the calculations for this are lots and lots of fun, so we're going to come back to that in the processing the data video. So meanwhile, Have fun, do a good job with the experiment, and I'll talk to you soon.